Hello and welcome to another video. In this one, we're going to be talking about fork and spawn. This came up during my recent stream where I was talking about why Flake 8 is much slower on Windows and Mac OS currently, and how I was able to fix it. But in order to explain that, I had to explain kind of the low levels of how processes work on POSIX-like systems as well as on systems that don't support fork. In order to do that, I kind of need to explain how fork and spawn work. But anyway, let's jump into it, and I will do that again. Okay, in order to explain this, we're going to kind of represent processes as blobs, and I'm going to give us a little paint diagram here. You can imagine this as being the parent process, and the blob is sort of their memory space, the code and data that's present in their process. And so you might have, like some global variables. We'll color those green. You might have program stack and all the other stuff. You might have a different global variable. It's like add another. It doesn't really matter. Just assume that there's some sort of like memory and some sort of state in the process. Now, what happens when you fork a process is you make a duplicate of your current process. Imagine this process forking a child process. We draw a little arrow doohickey here to indicate that we are forking here. Let's say this is fork. So fork will create a duplicate of the current process and spawn a child process. And this duplicate is not quite exactly the same. It basically references the same memory that the parent has, making fork extremely cheap. Basically just set up the PID metadata and then create a process. This memory here actually isn't copied. It is sort of like shadowed from the parent process. They share the same memory as long as they're reading from it. So it is what's called copy on write memory, or you may see the term COW, copy on write. This means that if there are read-only accesses in the child to this memory that it inherited from the parent, it won't need to write to them at all. It'll just read directly from the same memory that the parent has. However, if the child needs to make modifications to that memory, it will first copy the memory over from the parent and then modify it in place. So let's say that it wrote to some chunk of this red memory here. You might imagine that it has to overwrite this with a brand new chunk of memory. So let's say, well, draw that as blue here, and so it'll get its own memory for this chunk now, but still it'll inherit any of the stuff that it's doing in a read-only fashion from the parent process. So you don't incur a bunch of overhead to fork a process that's the same process and deal with the same memory. All right, so that's fork. Fork is supported on POSIX-like platforms, so Linux as well as Mac OS. However, there's a whole bunch of bugs in the Mac OS implementation of fork, so many languages and many runtimes choose to avoid fork even on Mac OS. Admittedly, there's a lot of problems with fork on Linux as well. Some of those that I don't completely understand, like there's a whole bunch of issues with like file descriptor inheritance and other mutable socket state and things that just are undefined behavior when you use fork. And so kind of the fix for this, or the replacement, or what's available on other platforms, is a spawn approach to creating processes. And what a spawn does, instead of creating kind of this shadow process that inherits memory, it instead creates a process completely from scratch. You get essentially a blank process. You do spawn here. If we call spawn, we essentially get a brand new memory space that doesn't inherit any of the memory from the parent. Now, another thing to mention here about fork versus spawn, this is one reason why if you have a big process that has a whole bunch of memory in it and you fork another process, you may get an out of memory error. This is because the operating system needs to guarantee that if all of this memory were made resident by writing to all of it, that it wouldn't run out of memory. And so you often get an out of memory error because it needs to essentially double the memory size by forking the parent to the child. This limitation isn't present with spawn because the memory starts from essentially 0 in the new process. It starts it over completely from scratch. Now, I wanted to talk about why this matters in Flake 8 and why you might want to think about this if you're writing programs, as well as kind of how you can reason about the performance trade-offs here. The first and kind of obvious performance trade-off is fork tends to be a little bit cheaper just because it doesn't need to build any process state, it doesn't need to run anything. It's already at the state of the program when fork gets called, whereas spawn needs to bootstrap a process from scratch. It needs to run whatever code necessary to get either the program in the right state or the Python interpreter in the right state or that sort of stuff. It needs to do a bunch of work to get to the start point. So the startup cost can be a little bit different. That's kind of the main trade-off here. Also, you just can't use fork on Windows. There's no fork implementation on Windows, and it's buggy on macOS, so that would be a reason to avoid it. Now, I want to show you a quick example in Python about how you can kind of differentiate and reason about this. It's going to take a little bit to write this out, so bear with me for a second. We're going to be using the multiprocessing library, and we're going to set a global variable. I know we shouldn't set global variables, but whatever. I'm going to make a function that takes an integer and returns an integer. This is going to be a function that we're going to call inside of our subprocess, and it's going to add that global variable with the value that we pass in. We're then going to make our main function, which is going to modify that global variable. I know we shouldn't use the global keyword, but it's the easiest way to show what's going on here. Name equals main, raise system exit main. And we're going to use the multiprocessing library to call this function. The easiest way to force a particular type of multiprocessing is there is this get context in the multiprocessing module that allows you to force either a fork or a spawn, or I think there's also a spawn server, which is a whole different thing. But you can use multiprocessing.getContext. So let's say we want to force fork. Inside the context basically returns, it's not exactly a copy of the multiprocessing module, but it acts like it. So you can call, the multiprocessing pool constructor from there and get yourself a pool. And then we're just going to map over this value. That way we can see the side effect of setting that global. So if we print list p.map x, let's just pass in a tuple 1, 2, 3, 1, 2, 3. Hope that's the right number of parentheses. And we also want to reassign this global to 2. Okay, so what's going to happen here is we're going to start the parent process. It's going to modify this global variable. It's going to become 2. And then we're going to fork 2 child processes. So we're essentially going to do this, shadow process thing here, but we're going to get 2 copies of the parent process. Note that when we fork, essentially when this runs here, it will inherit any of the state of the parent process. So this modification, it's a global modification. The child processes will see that because it's fork. And so we should expect to see 2, 4, 5, or sorry, I can't. 3, 4, 5. Yeah, I can add 1 and I can add 2. That's simple math here. So we should expect to see a list that's 3, 4, 5 here. And so if we go ahead and run this, you'll see that we get 3, 4, 5 here. This is because the child processes inherited the global state of the process. This is what currently happens in Flake 8. The way plugin options work is they're essentially global variables stored on the class, which I would love to fix at some point, but it's really hard to untangle given the breadth of the plugin ecosystem. So someday I'll try and make that less global variably, but I have a hacky workaround that makes this work on Linux, or makes this work on macOS and Windows anyway. All right, now I want to show you what happens with spawn instead of fork. Actually just print fork, that way we know what we're doing here. Should have done that before. Print spawn, and we're going to get a spawn context instead. Now in a spawn context, we're actually bootstrapping the process completely from scratch. So you'll see from my drawing here, we start from scratch. We don't inherit any of this global state, and so this glob up here at the top, this assignment here doesn't happen to glob here. It's just going to inherit whatever happened at the module level. Python essentially tries to import whatever function is here. So it's going to find this X module or this X function here. Glob doesn't get modified because main never runs. And so you'll not see any of that process state inherited in the children. So we should instead see 2, 3, 4 here for spawn. So if we run this now, you'll see we get 3, 4, 5 for fork and 2, 3, 4 for spawn. And that's kind of the difference here. So what happened in Flake 8 is on platforms that didn't have fork, where it was running spawn, none of the plugins got configured, and so everything just sort of crashed. They didn't have their options, they didn't know how to operate, it didn't work. I made a very clever hack, which I hope to eliminate at some point when I make the plugins more reasonable and not depend on global state. But for now, what this does instead is it reinitializes the global state in the child process. So you'll see, yes, I have to use global variables to kind of solve this, but it reinitializes all of the plugins and options on any of those child fork processes. So a little bit slower than just doing it linearly because it has to do this process initialization twice. But when you have multiprocessing, it tends to be much, much faster to use your 32 core machine or even your 2-core machine to speed up Flake8. But anyway, that's fork versus spawn. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.